All right, the second mistake I made on the last video is that was example 4, not example 3, but hopefully you figured that out. All right, we're gonna look at example 5. Again, please look at the book because the picture in here is three-dimensional and clearly mine is not. But it says a manufacturer drills a hole through the center of a metal sphere of radius 5 inches, as shown in the figure. We'll look at the book, it's much nicer there. The hole has a radius of 3 inches. What is the volume of the resulting metal ring? Okay, so what's happening here is this is actually a sphere, so a ball, not just a circle, and then we're cutting a hole through the middle of it like this. Okay, so now it has a hole in it like that. So this is the part that's shaded and it's being rotated around. So imagine it like a whole ball with this just metal part, this hole through this part of it. Over here as well. That should be dotted. You get the idea. Again, look at the picture in the book. It is much better than mine. All right, and also this one is very crooked. So to do this, we're going to need some formulas. We're going to need some functions to work with. So this is the region that we want to focus on. This is the region that we're rotating around the x-axis, okay? So we need the formula for a circle. So circles are x squared plus y squared equals the radius squared, and this one had a radius of 5. Now, when we slice this is going to be a washer method. You can imagine all of these washers, and they have a hole straight through the middle of them. So this will be in terms of x. Okay, so we need to solve this for y. So y squared is 25 minus x squared. Now, technically, that should be the plus or minus square root, but we don't need to worry about that because we're only looking at the top half. The negative one would be down here. We only need the top one. All right, so we are clearly looking at washer method, okay? If you think about one of the washers that we slice, this is what it looks like, and it has this hole in the middle of it. So washer method is still over there. Volume is pi r squared. From where to where? Let's see. We need these points. So we are looking for the place where this function intersects with 3. This was what, y equals 3. Let me look at that. It was 3 inches, yeah. Oh, x equals 3. That's y equals 3. Nope, it was y equals 3. All right. So if y equals 3, we can set these two things equal to each other. So square both sides, we get 9 equals 25 minus x squared. Rearrange that. So x equals 4. Okay, so we are going to be going from -4 to 4 are those 2 points. All right, our outer radius, this outer radius part is defined by this function. So we're going to do the outer radius squared minus the inner radius is defined by this function. And notice the inner radius is the same no matter where we are. So the inner radius is just 3. And these are dx's. We already discussed that. Okay, so this is our setup that we need. So that square root and square is going to cancel out. So we get 25 minus x squared minus 9. So we get 16 minus x squared. We'll take the antiderivative. We get 16 minus 1/3 x cubed. We're going to evaluate from 4 to -4. I'll let you do the arithmetic of plugging that all in, but I did write down the answer. 256 pi over 3.